Next problem, fifth one. F of x is equal to root of 2 minus x plus root of 1 plus x. So we have got root of 2 minus x and root of 1 plus x. We have to find the domain of this and domain of root of 1 plus x. And finally, we have to take all the common values which satisfy both, or the intersection of both the sets. Now 2 minus x greater than or equal to 0 implies 2 is greater than or equal to x, and this implies x is less than or equal to 2. And here 1 plus x is greater than or equal to 0, x is greater than or equal to minus 1. So for the first one, if here is minus 1 and here is 2, we have to take all the values like this, minus 1 to infinity. And here, including this 2, we have to take from this side. So therefore, we will accept all the values which belong to minus infinity, common values of minus infinity to 2 and minus 1 to infinity. Therefore, finally, the domain is minus 1 and 2. Therefore, the minus 1. So therefore, domain f is equal to minus 1 comma 2. This is the final answer. F of x is given as x minus alpha into beta minus x. Now x minus alpha into beta minus x greater than or equal to 0. Coefficient of x square is positive, is negative, expression is positive. So the coefficient of x square and the expression are having opposite signs. Therefore, x lies in between alpha and beta, and it is given as alpha is less than beta. Therefore, alpha is less than or equal to x is less than or equal to beta. Therefore, domain f is equal to alpha comma beta closed interval. Now f of x is equal to 1 by square root of mod x minus x. Square root of mod x minus x is under the root and is in the denominator. Since it is in the denominator, it cannot be equal to 0. It is under the root, it should be positive or 0. So therefore, for both, modulus of x minus x should be greater than 0. And modulus of x minus x is greater than 0. This implies mod x is greater than x. And mod x will be greater than x only if x is negative. When x is negative, this value will be negative value and this value will be positive. So naturally positive value will be greater than the negative value. Therefore, x belongs to minus infinity to 0. Therefore, domain f is equal to minus infinity 0. So 1 by root of mod x minus x. Mod x minus x should be greater than 0. Mod x must be greater than 0. If x is negative, this value will be negative. Because of the modulus, this will be positive. Therefore, positive value will be greater than the negative value. Therefore, x should be negative. That means x should be minus infinity to 0. Therefore, the domain is minus infinity 0. Next problem, f of x equal to square root of mod x minus x. The difference between this problem and the previous problem is, in the previous problem this value is in the denominator, now it is in the numerator. Now modulus of x minus x must be greater than or equal to 0. Therefore, mod x is greater than or equal to x. So now, mod x will be greater than or equal to x for all values of x. For example, if you take 4, modulus of 4 satisfy greater than or equal to 4. Suppose if you take minus 4, modulus of minus 4 will satisfy greater than or equal to minus 4. So therefore, x can take any real value. Therefore, domain of f is capital R or minus infinity to infinity. Now find the domains of the following real valued functions once again. Find the domains for the following real valued functions. Number 1, 1 by root over step x whole square. Step x is greatest integer function. Minus step x minus 2. The second one, log of x minus step x. The third one, log of root of 3 minus x by x to the base 10. The fourth one, a root of x plus 2 plus 1 by log of 1 minus x to the base 10. The fifth one, root of 3 plus x plus root of 3 minus x by x. Now, the first one, f of x is equal to 1 by square root of step x whole square minus step x minus 2, and we very well know that step x is greatest integer function. Now step x whole square minus step x minus 2 should be greater than 0, and the factors, this is step x minus 2 into step x plus step x minus 2 greater than 0, and step x, if you take common, this is step x minus 2 plus 1 into step x minus 2 greater than 0. That means step x minus 2 into step x plus 1 greater than 0. Coefficient of step x whole square is positive, expression is positive. Therefore, step x should be less than minus 1 and step x should be greater than 2. Step x less than minus 1 implies x is equal to, or step x equal to -2, -3, -4, etc. So this implies x is less than -1. And step x greater than 2 implies step x is equal to 3, 4, 5, etc. That is, x is greater than or equal to 3. So here x should be less than -1, here x should be greater than or equal to 3. Therefore, finally, domain F is equal to -infinity, -1, union 3 to infinity. Next one, f of x is equal to log of x minus step x and here x minus step x is inside the logarithm. Logarithm of something means that something should be greater than 0. Therefore, x minus step x should be greater than 0. That is, x should be greater than step x. This implies x is not an integer. Because step x is integer, x greater than step x is possible only when x is not an integer. Therefore, x minus step x greater than 0 implies x greater than x, and this implies x is not an integer. Domain of f is equal to r minus set of integers z. That means we have to delete all the integral values from the real numbers set. Next one, f of x is equal to log of root of 3 minus x by x to the base 10. And log of something to the base 10, base is positive and is greater than not equal to 1. Therefore, as far as the base part is concerned, it is clearly given. And here this value is under the logarithm, so it should be positive. And 3 minus x by x is inside the square root. Therefore, it should be positive. And x is in the denominator, it should not be equal to 0. So fx is equal to log of 3 minus x to the base x to 3 minus x by x to the base 10. Entire thing is under square root. So now log of 3 minus x by x to the base 10 is under the square root. Therefore, log of 3 minus x by x to the base 10 must be greater than or equal to 0. Therefore, 3 minus x by x is greater than or equal to 10 power 0. This implies 3 minus x is by x is greater than or equal to 1. This implies 3 minus x is greater than or equal to x. This implies x is less than or equal to 3 by 2. This is according to the square root. Now, 3 minus x by x, it is within the logarithm, therefore, it should be greater than 0. For this, 3 minus x is greater than 0 and x is greater than 0. This implies x is greater than 0 and x is less than 3. Therefore, 0 is less than x is less than 3. Minus infinity to 3 by 2. And now, the another interval is 0 to 3. Now we have to take all the common values which satisfy both. So if we take the number line, 3 by 2 will be here somewhere, 3 will be here somewhere, 0 will be here. According to this, we have to take the values from here to here, and according to this, we have to take the values from here. Therefore, the values which satisfy both are the values from 0 to 3 by 2. 0, 3 by 2. Now the next one is f of x equal to root of x plus 2 plus 1 by root of log of 1 minus x to the base 10. Root of x plus 2 is within the square root, therefore x plus 2 must be greater than or equal to 0. This implies x is greater than or equal to minus 2. And log of 1 minus x to the base 10 is in the denominator, it should not be equal to 0. So 1 minus x is equal to 10 power 0, 1. That means x not equal to 0. The next one is 1 minus x is within the logarithm, therefore 1 minus x is greater than 0. X is less than 1. So here it is greater than minus 2, here it is not equal to 0, and there it is less than 1. If you have minus 2 here, 0 here, and 1 here, this should be greater than or equal to, and this is less than 1, and 0 is not valid. So therefore, the values which satisfy both, here all the values from minus 2 greater, and all the values from 1 and on this side. So the values which satisfy both are the values which belong to minus 2 comma 1. And from that, we have to delete 0. So therefore, x plus 2 greater than or equal to 0, x greater than minus 2. Since it is in the denominator, log of 1 minus x to the base 10 not equal to 0. That means 1 minus x is not equal to 1, hence x is not equal to 0. And 1 minus x is inside the logarithm, it should be positive. So 1 greater than x or x less than 1. So here minus 2 and so on up to infinity. According to this, 1 to minus infinity or minus infinity to 1. 0 cannot be taken. Therefore, the values which satisfy all will be the values for the domain. Therefore, the domain f is minus 2 to 1, one is not having equality. From this, we have to delete the set 0. So it is minus 2, 1, and 0 is removed from that interval. Function is f of x equal to root of 3 plus x plus root of 3 minus x whole by x. So this value is under square root, this value is under square root, this can be greater than or equal to 0, this is greater than or equal to 0, and this is in the denominator, x is not equal to 0. So first one is 3 plus x is greater than or equal to 0. This implies x is greater than or equal to minus 3. The second one, 3 minus x greater than or equal to 0. This implies x less than or equal to 3. And x is in the denominator, it cannot be 0. So, according to this, if minus 3 is here and 3 is here, we can take all the values like this here from this, and 0 is to be eliminated. So therefore, from minus 3 to 3 closed interval, we can delete 0. Therefore, so first one, 3 plus x greater than or equal to 0 implies x greater than or equal to minus 3. 3 minus x greater than or equal to 0 implies x less than or equal to 3, and x is not equal to 0. So therefore, the domain is equal to, from the closed interval minus 3 comma 3, we have to delete 0. Or you can write this as minus 3 to 0. This is left close, right open, union 0 to 3. Sixth problem, f of x is equal to 1 by x square minus 1 into x plus 3. Now x square minus 1 is not equal to 0. X plus 3 is not equal to 0. Here x is not equal to plus or minus 1. Here x is not equal to minus 3. So all the values which satisfy both the conditions are x should not be equal to plus or minus 1 and minus 3. Therefore, from the set of real numbers, we have to omit minus 3, minus 1, 1, and this is the domain. Therefore, the domain is, domain f is equal to or minus minus 3, minus 1, 1. The next one, f of x equal to 2x square minus 5x plus 7 by x minus 1 into x minus 2 into x minus 3. So this is in the form fx by gx, and 2x square minus 5x plus 7 can have any real value for x. But for the denominator, x minus 1 not equal to 0, x minus 2 not equal to 0, x minus 3 not equal to 0. Therefore, x is not equal to 1, x is not equal to 2, x is not equal to 3. Therefore, from the real numbers set, we have to omit the 3 numbers 1, 2, 3. Therefore, domain f is equal to capital R minus 1, 2, 3. Next one, f of x is equal to 1 by log of 2 minus x. Log of 2 minus x is in the denominator, hence log of 2 minus x should not be equal to 0. And 2 minus x is within the logarithm, therefore it should be positive. So log of 2 minus x not equal to 0. This implies 2 minus x not equal to 1, because for log 2 minus x the base is e power 0 is 1. Therefore x is not equal to 1. And here 2 minus x is greater than 0, therefore x is less than 2. So x is less than 2 and x is not equal to 1. X is less than 2 means x belongs to the interval minus infinity to 2, and from this we have to eliminate 1. This is the domain. Therefore domain f is equal to minus infinity to 2 minus 1, or if you take the number line, this is 0, this is 1 and this is 2. We can get any value less than 2 except this 1. Therefore it is minus infinity to 1 union 1 to infinity, 1 to minus infinity to 1 union 1 to 2. So better to write this only. Next, f of x is equal to modulus of x minus 3. Modulus of x minus 3, modulus x is defined for all real numbers. Therefore x belongs to R is the domain for modulus function. Next one, f of x equal to square root of 4x minus x square. 4x minus x square is within the square root, hence it should be greater than or equal to 0. If you take x as common factor, x into 4 minus x is greater than or equal to 0. Now once again this is a quadratic. Coefficient of x square is negative and the expression is positive. One is negative, another is positive, means both are having opposite signs. Hence x lies in between 0 and 4. Therefore 0 is less than or equal to x is less than or equal to 4 is the domain. So the domain f is equal to 0 less than or equal to x less than or equal to 4, or simply you can say domain f is equal to 0, 4, the closed interval. Now f of x is equal to 1 by square root of 1 minus x square. F of x is equal to 1 by root of 1 minus x square. 1 minus x square greater than 0. This implies 1 minus x into 1 plus x greater than 0. Coefficient of x square is negative, expression is positive. This implies minus 1 is less than x is less than 1. Therefore, domain f is equal to minus 1, 1. 1 minus x square greater than 0 implies 1 minus x 1 plus into 1 plus x greater than 0. This implies minus 1 is less than x is less than 1. Since coefficient of x square is negative and expression is positive, x lies between these two. Therefore, the domain is minus 1, 1. Now f of x is equal to 3 power x by x plus 1. 3 power x is an exponential function for which the domain is capital R. So, for 3 power x, domain is capital R, and x plus 1 not equal to 0 implies x is not equal to minus 1. So we can give any real value here and minus 1 is to be eliminated. Therefore, the domain which satisfies both is r minus minus 1. Next one, f of x equal to square root of x square minus 25. And square root of x square minus 25 is a root. Therefore, x square minus 25 is greater than or equal to 0. Therefore, x minus 5 into x plus 5 is greater than or equal to 0. Coefficient of x square is positive, expression is positive, hence x cannot take any value which lies between minus 5 and 5. So therefore, x should be less than or equal to minus 5 and x should be greater than or equal to 5. Therefore, domain f, so x square minus 25 greater than or equal to 0, factors x minus 5 into x plus 5 greater than or equal to 0. Coefficient of x square is positive, expression is positive. Therefore, x cannot take any value between minus 5 and 5. So, x should be less than or equal to minus 5 and x should be greater than or equal to 5. Therefore, domain f can be written as minus infinity to minus 5 union 5 to infinity r minus now f of x is equal to root of x minus step x. Suppose if we take x is equal to some 4, step 4, 4 minus 4, 0. Suppose if we take 3.5, 3.5 minus step 3.5 is 3, positive. Suppose if you take x is equal to some minus 2, this is minus 2. From f of x is equal to square root of step x minus x, and step x minus x must be positive. That means positive or 0, and step x should be greater than or equal to x, and this is possible only when x belongs to z. Therefore, domain f is equal to